Greetings of the day to all. I am Shikha Kansal and we will be talking about hypothesis testing one tail and two tail test, one directional or non directional test, or we can say not directional test. So, what we are supposed to talk about is one side, that is one tailed, and if it is both the sides it is non directional. One sided test is a statistical hypothesis test in which the values from which we can reject the null hypothesis, that is H naught, are located entirely in one tail of the probability distribution. One tail means onto either of the two sides of the bell shaped curve. Lower tailed, that means we will reject the null hypothesis if the sample mean is significantly lower than the hypothesized mean. That means H naught is the your null hypothesis. This is null hypothesis. This means H naught, naught means 0, 0 means not significant, or we can say that we know that it will going to be rejected. We are giving it 0 preference, 0 significance, that is why we are saying H naught. And alternate hypothesis, as I have told you, alternate hypothesis, something which will be accepted and it is designated as H A or H 1, depends which one you want to write down, whether you want to write down it as H A or you want to write down as H 1. So, null hypothesis is equal to, this is called as the mean, because what we are writing here is that the mean is significantly lower than the hypothesized mean. That means, your mu is mean, this mean is equal to mu naught, that means mean for null hypothesis, and whereas alternate means that the mean which we are taking is less than the hypothesized mean, that means mu naught. When we are talking about one tail test, one tail means that here this is mu naught is equal to mu 1, and one tail means the either of the two tail, either this is representing H naught or might be this part. We can represent, I can make another graph for you where this might represent as H naught, this part is your H 1 or we can say H A, this all is the accepted region and this is rejected region. Here your mu naught is equal to mu 1, this is the height of your bell shaped curve, in which when we are talking about one tail test, that means either of the two tails, either this tail or this tail. Onto this graph we can see either of one tail has to be rejected. That means, we know as to which direction we are working on and onto which direction our statistics are going on when we are talking about hypothesis. So, when we are talking about lower tail test, that means it is left hand side test. Left hand side means when you see the graph, when you see the bell shaped curve, left side means this, that means this is left side, and we are talking about this, this is right side. When talking about left side, that means the lower tailed test will reject the null hypothesis, that is H naught, if the sample mean is significantly lower, that means your mean is lower than the hypothesized mean. That means, this is a lower tail test in which your mu is less than mu naught, that means your mean is less than your hypothesized mean. In the case when there is a less than sign between the mean and the hypothesized mean, your one tail test, that is called as a lower tailed test, that is called as a left hand side tail test when we talk about hypothesis. For example, a wholesaler buys light bulbs from the manufacturer in a large lot and decides not to accept a lot unless the mean life is at least 1000 hours. That means, what could be the solution of this question? Solution could be, we are supposed to assume a null hypothesis and the alternate hypothesis. Null hypothesis says my mean should be equal to 1000 hours, whereas my alternate hypothesis says that my mean has to be less than 1000 hours. This less than says this is a left hand side test or one tail. This is a left hand side tail test when it is a one tail test. So, therefore, we reject null hypothesis only if the mean life of the sampled bulbs is significantly below 1000 hours. That means, if my mu here is coming out to be less than 1000 hours, then we will reject the null hypothesis that mu is equal to 1000 hours. Otherwise, we will accept the null hypothesis. In this case, if we draw the curve, if we draw the bell shaped curve, this bell shaped curve turn out to be, this is H naught rejection area and this is acceptance area of H1 or H naught. This part, your mean mu is equal to mean, the hypothesized mean is equal to your actual mean of the sample. Now, this is a point, this is called as a critical value, which we will be studying how to point this line. This is called as a critical value, which we will be studying further in this PPT, and from where to find out what this value could be. This area, this hole is, we can take it as 1000 sample of bulbs, that means this hole shows 1000 bulbs, whereas this is the part of H naught, that is null hypothesis, and the acceptance area is called as the alternate hypothesis. If your sample mean, that means the sample mean life of the sampled bulbs turn out to be significantly less than 1000, then we are going to reject our null hypothesis and we will accept the alternate hypothesis. Now, this was the left hand side tail which we was this is the left hand side tail which we have just studied. Next comes out to be a right hand tail test, in which we will reject the null hypothesis if the sample mean is significantly higher than the hypothesized mean. That means, your null hypothesis is equal to mean is equal to your null hypothesis, your sampled mean, whereas your hypothesized mean, here hypothesized mean is less than your sample mean, then it is a upper tail test, which is supposed to be a right hand side tail test. This is called as H naught, which is supposed to be rejected, and this is H1, this area is acceptance area. Fine. Again, this is a part which is called as a critical area, or you can say critical point, which will tell me that at this point, after this point, it has to be a rejection area, and before this point it has to be a acceptance area. It totally depends upon this critical point. What happens here is, if my null hypothesis is, in null hypothesis, if my mean is equal to my mu naught, and in my alternate hypothesis, if my actual mean of the sample is greater than the hypothesized mean, then I will going to reject my null hypothesis if the sample mean here is significantly lower than my hypothesized mean. Then the tail test is called the upper tail test. That means, in the earlier one we took mu less than equal to mu naught, and this was the case when we were talking about left hand side test. But in right hand side, this is also called as right hand side test. Right hand side means upper tail test, in which you always take your sample mean greater than your hypothesized mean. For example, a highway safety engineer decides to test the load bearing capacity of 20 years old bridge. The minimum load bearing capacity of the bridge must be at least 10 tons. So, in this case, if I take my null hypothesis is equal to my mean is equal to 10 tons, and my alternate hypothesis says my mean is greater than my hypothesized mean. That means, I have taken my hypothesized mean to be less than the mean sample mean. That means, my sample mean is significantly higher than my hypothesized mean. That means, this sample test is talking about my right hand tail test, in which I am rejecting my null hypothesis only if the load bearing capacity of the bridge is significantly higher than 10 tons. That means, it will talk about, we are talking about our right hand tail test, in which this shows my H naught, which I know will be rejecting, and this is my H 1, which is acceptance area. This shows my acceptance area, and this shows my rejection area, where this is a critical point which divides the acceptance area and rejection area by a single point, which is called as the critical point. This point is a place where my actual mean is equal to my hypothesized mean, that is mu is equal to mu naught. So, in case when we are talking about a right hand test, we are supposed to reject the mean, the null hypothesis only if the mean load bearing capacity of a bridge, that means my H naught is significantly higher than my hypothesized mean. So, if my mu naught is greater than, if my mu is greater than mu naught, I will going to be doing the right hand test. Otherwise, if my mu is less than mu naught, then I will supposed to talk about left hand side test. Now, there is a two tail test in which we are supposed to talk about mean again, where the two tail test will reject the null hypothesis if the sample mean is significantly higher than or lower than the hypothesized mean. That means, if I have a bell shaped curve, then this is my H naught, this is also my H naught, this is my mu is equal to mu naught, where my mean, the sample mean is equal to my actual mean, my hypothesized mean, my actual mean is equal to my hypothesized mean, that is mu is equal to mu naught. This area is acceptance area, and this is rejection area. Along with this is also a rejection area, and this whole part is the acceptance area. This point gives me the critical value. In the same manner, this will also be a critical value. Taking an example, a manufacturer of light bulbs wants to produce light bulbs with a mean life of 1000 hours. If the lifetime is shorter, he will lose customers to the competition or the competitor, and if it is longer, then he will incur a higher cost of production. He does not want to deviate significantly from 1000 hours in either direction. As to how to get a null hypothesis and alternate hypothesis is just see here. If I take my null hypothesis where mean is equal to 1000 hours and I take my alternate hypothesis where my mean is not equal to 1000 hours, then since we are not knowing as to which direction we are supposed to follow, but we know that there is some relation between 1000 hours and the number of customers. So, what happens is I will take it as two-tailed test. That means, in either of the two directions I am supposed to reject or accept my null hypothesis. That means, I will take the two-tailed test as shown in the figure above, in which I will accept the major region and I will reject the null hypothesis if the statistics says that. Now, what we were talking about was something called as a critical value earlier. So, what is that? The level of significance is denoted by alpha. That means, I am supposed to denote this as alpha here, fine. Now, the testing the validity of H naught against H 1 at a critical level of significance is called as alpha. The level of significance denotes the probability of rejecting the null hypothesis when it is true. The value of alpha varies from problem to problem, but generally we take it as 5% or 1%. The confidence with which an experimenter, the researcher, rejects or retains or accepts a null hypothesis depends upon the significant level adopted. That means, if at 5% level of significance means there are 5 chances out of 100 that the null hypothesis will be rejected when it should be accepted. Whereas, if we say 1% level of significance, that means there is 1 chance out of 100 that the null hypothesis will be rejected when it has to be accepted. This means that the researcher is 95% or we can say 99% confident that he is taking the right decisions. This totally depends upon the significant level which we are taking in the question or the problem which the researcher is researching on. So, how to set up a suitable level of significance? When the hypothesis in the question is accepted at 5% level of significance, then the statistician is running a risk that is that in long term, in long run, he will be making a wrong decision about 5% of times, but 95% of times he is right. That is, he runs the risk of rejecting a true hypothesis, a true values or a true situation in 5 out of 100 occasions. Therefore, it is seen that the confidence with which the researcher reject or accept null hypothesis depends upon the level of significance, or we can say the level of confidence. This level of confidence comes to the researcher along with his experience, his expertise, his knowledge. By testing, whereas by testing at 1% level of by 1% level of significance, the statisticians seek to reduce the chances of making a false statement, but some elements of risk remains 1 out of 100 occasions. That means, he is taking wrong decision only one time out of 100 chances. So, what happens here is, if he is taking only the risk of 1%, that means out of 100 times he is taking the risk 99% time it is true, but 1% time one chance is there that he might take a wrong decision, and that 99% chance times is the time when the researcher is making a right decision. So, what happens is, this diagram here I will show you how to accept and how to reject. This diagram shows you 5% level of significance. If we are talking about 5%, we cannot write 5%, but what we write it as? We write it as 0.05, because we cannot write down percentages, but what we are writing here is, we are writing it in normal terms, that is converting it to normal numbers, that is equal to 0.05. How to illustrate a region in which we would accept or reject the null hypothesis when it is two-tailed test is employed. It may be noted that 2.5% of the area under the curve is located on each tail. Why? Because we are talking about 5%. If 5% is to be broken into two parts, that means 0.25%. If 5% is broken into two parts, that means it will be equal to 5% divided by 2 is equal to 2.5% on either of the two sides, that means is equal to 0.025. Therefore, when we are talking about two-tailed test, 0.25 onto the one side and 0.25 0.0 to 0.25 onto the other side, whereas when we are talking about one tail test, that means whole of the 5% has to lie onto the one side and or either on the one side onto the left side onto the right side, but here we are talking about a two tail test. Two tail test means if this is my critical value which is separating my H naught to H A, that means null hypothesis and the alternate hypothesis area. Therefore, this part is called as H naught. In the same manner on the other side as well, this is called as critical value and this is null hypothesis. That means the areas, the sides, the two tails of this bell shaped curve is, this area is rejection area as well as this side it is rejection area. Along with this, this area is only 0.025, this area as well it is only 0.025 of the area which is this, which is 0. Out of 100% we have already taken 5%, so 95% remains, so it is 0.95. So, what happens here is, this is my point at which my mu is equal to mu naught and this is my acceptance region and these both regions are my rejecting areas. This is the area which is called as acceptance. What do you mean by acceptance and rejection area here is, this acceptance area shows that my answer or values lies in this portion, whereas if we are accepting this area, that means my answer after doing the test lies in this portion, whereas if I say my answer lies in this part, that means I will not reject this area, but I will accept this area and this leads to one of the error which we talk about. Therefore, this is the area in which my answer belongs to when I am accepting this area and I am rejecting the other parts, the tails of the problem, whereas if I am rejecting the major part and I am accepting the tails, then that means that leads to an error, or might be this leads to acceptance only when my answer is putting into this part. So, this is one diagram which talks about the how to interpret a 5% level of significance. In the same manner, we can also work on 1% level of significance. That means converting 1 into points gives you 0.01%, 0.01 significance level. This is how we work for 0.05% level of significance, or we can say 5% level of significance. Now, just taking a quick review as to how to go through, how to find out a suitable significance level and how to go for two tail test. Just see, when we were talking about one tail test means, one tail means the tail, the rejection area is onto the either side, either onto the left side or onto the left side, but not onto the both side of the bell shaped curve. Whereas, when we talk about two tailed, that means my rejection area, that means my null hypothesis should lie onto both the sides of the bell shaped curve. That means, when we talk about one tailed, And when we talk about two-tailed test means the directions are not clear as to which direction we are supposed to go on, whereas in one-tail we are clear as to which direction we are supposed to follow. And significant level, if we talk about significant level, we are talking about only 5% significant level here, but yes, we have one more, that is called as 1% significant level, in which if we are taking 1% level of significant, that means there is 1% level of chances that the statistician seeks to reduce the chances of making a wrong decision, making a false statement, but there are some elements of risk. What is that element of risk? Is only 1 out of 100 occasions that he is supposed to take wrong decision. That means, for example, if we are saying smoke causes cancer. Now, my null hypothesis says there is a direct relationship between smoke and cancer. My alternate hypothesis says smoke does not have any relationship with cancer. I know that my null hypothesis will going to be rejected, because ultimately I too have a gut feeling, being a researcher, that smoke do have an impact on the lungs of a person. So, thus it causes cancer, we can say lung cancer or any other cancer. So, what happens here is, if I know my null hypothesis is going to be accepted, that means I am making a mistake here, because null hypothesis itself talks about that there are few percent of chances that it is supposed to be accepted. Only 1% chance is there. When we are talking about one level of significance, that means there is only 1% chance that I am taking wrong decision out of 100 chances. So, when we are talking about this question, this problem, then null hypothesis talks about smoke causes cancer, there is a direct relationship, there is no, when I am talking about smoke and cancer are not related, then this is something which is making a false statement. But yes, if we are talking about 5% level of significance, that means out of 100 times, if I am taking the judgment 100 times, that means I am making false statement 5%, 5 times out of 100. So, this is what all about significant level, and this is the diagram which talks about significant level at talks about the regions of significance level at 5% and 1%. If it is 5%, we are supposed to distribute 5 divide by 2, that is gives you 2.5%. 2.5 means 0.25, 0.025 onto either of the two sides. In the same manner, if we have 1% level of significance, divide by 2, it gives you 0.025. I hope I have made the things of significant level and the two-tailed test and one-tailed test very much clear to you. That is all from my side. Thank you so much.